Hello and welcome. In this video tutorial, we're going to take a look at the solutions to the homework for Unit 8, Lesson 4 on the volume of prisms and cylinders. Please remember to rewind and pause the video as necessary. Let's begin. Problem number 1. The following wedge prism has a volume of, now to find the volume of a right figure, okay, a right prism, you're going to essentially take the volume is the area of the base, which I'm going to call base area, times the height, or depth in some cases. In this case, it's going to be depth for this problem. So what we're going to do is we're going to take essentially the area of this triangle that you see right here, and we're going to multiply it times that depth of 6 inches, which I guess kind of represents the height in this problem. So base area is going to be that of a triangle, which is 1/2 the actual base times the height of the triangle, which, as you can see in the problem, is 1/2 times 2 times 4.5. Now the 1/2 and the 2 cancel, which means the area of the base is essentially 4.5 square inches. Now the volume is going to be 4.5 square inches times the depth, which is in this case 6 inches. And when we multiply those two together, we get 27. And if you multiply inches squared times inches, we get inches cubed. Now we don't say inches cubed. We call this cubic inches. That would be how you say that. That would be option number 3. Question number 2. A right circular cylinder. Okay, so let's draw it first so we can visualize this. So draw a circle, draw a wall, another wall with another circle on top. There's your cylinder. Now the cylinder itself has a diameter of 14 inches going all the way across it. And it has a height of 10 inches. Well, if the diameter is 14 inches, the radius, of course, would be 7 inches. And you know you need the radius. So the volume for a cylinder, which I'm going to call VCY, is it's the same. It's the area of the base times the height. But now the area of the base is a circle. So you're going to multiply the area of the circle times the height, or the stack of circles. So the base area itself becomes pi r squared times h. So we're going to go pi times 7 inches squared times 10. Now you can see you're supposed to leave your answer in terms of pi, hence all those answers with pi in them. So I'm going to multiply this together and I get 49 times 10, which is 490 pi. And that is option number 2. Number 3, a box tube is constructed out of a 1 centimeter thick metal that has a width of 10 centimeters and a height of 6 centimeters and a depth of 15. Which of the following represents the volume of the metal used? Okay, so I'm going to describe this the following way. So essentially, you can look at this, the volume of the tube right there, as the volume of the big box. There's a big box right here, this big box that I'm tracing out, minus the volume of this little box inside, which represents the empty space. So if we take the volume of the tube, the volume of the box tube, which I'm going to call VBT, is equal to the volume of the big box, BB, minus the volume of the small box, SB. So we're going to find those two volumes and subtract them. Okay, so volume of the big box well, that's going to be, we need essentially length times width times height, or area of the base times height. Now, for a rectangular prism, again, the volume would be base area times height. So let's find the base area. Okay, so this is for the big box. The base area of the big box is going to be 10 times 15. Right? Or 150 square centimeters. Now the volume of the big box is just going to be the area of that base that we just found times the height. In other words, we're going to multiply it times the height of 6 inches. So 150 centimeters squared times 6 centimeters would be 900 cubic centimeters. So that's the volume of the big box, the outer box. The volume of the inner box, well, let's look at the dimensions. You're going to have the same area of you'll have the same length. The length will still be 15, but the height is going to be different. The height is 1 inch less. So you have 1 inch here, 1 inch here, 1 inch here, and 1 inch here. So in other words, if we take 10 inches minus 1 inch plus 1 inch, that means this is really 8 inches wide and 4 inches tall. In other words, we have to subtract 2 inches from that. So let's find first the small box. Let's go ahead and find the base area. The base area is going to be 8 times the 15. Okay, so in other words, I'm not going the full 10 like I am here. I'm going only 8, but it's 8 times the whole 15. And for that, we get 120 cubic centimeters. The volume of the small box would then be the base area times the height, which is 120 square centimeters, times a new height of 4 centimeters. It's only 4 centimeters tall, not 6, which would be 480 cubic centimeters. So the actual volume of the box tube itself is going to be the 900 minus the 480, which comes out to about 420 cubic centimeters. And that's option number 1. Number 4, a large plastic bucket in the shape of a right circular cylinder with dimensions as shown if there is 1,000 cubic centimeters in a liter and 3.785 liters in a gallon, then which is true about the volume of the cylinder? Okay, so basically, let's find, since the units are originally in centimeters, first find the volume of this cylinder in cubic centimeters. Use the units that are already given. Then we will convert this to liters. Then we will convert this to gallons, because we have what are called conversion factors to go from cubic centimeters to liters, then to gallons. Okay, so the equation is the volume of the cylinder, of a right cylinder, is the area of the base times the height. And the area of the base is, of course, a circle down at the bottom. So in other words, it's going to be pi r squared times the height. So we're going to go pi, the radius is 15, so pi times 15 squared, times the height of 28. And the volume of the cylinder, we get about 19,792 cubic centimeters. Now, we're going to take that same number, and here's what we're going to do. We're going to multiply this times a conversion factor. And here's the conversion factor. We have 1,000 cubic centimeters in 1 liter. So what I want to do is I want to first start by placing my units. Cubic centimeters has to go down here so that it can cancel with that. And I'm going to put 1 liter in 1,000 cubic centimeters. Notice cubic centimeters cancels. I'm going to multiply times a second conversion factor to go from liters to gallons. So I want liters to be down here and gallons to be up here. Liters cancels. Now, next to gallons, we have a gallon, so 1 gallon. Next to liters, we have 3.785, right? And so the math kind of takes care of itself. Here's what we're doing. We're going 19,792 times 1 is 19,792. And then on the bottom, you're going 1,000 times 3.785, which is 3,785. Notice all the units canceled except for gallons. When you divide these two, you get 5.22 gallons. Now, that falls between 5 and 6 gallons. Number 5. A piece of hardware is constructed by drilling a cylindrical hole through a right prism with a square base that measures 20 millimeters on each side. The hole is 35 millimeters long as shown in the diagram. Determine the volume of the remaining material. So basically, to find the volume of that outer material minus, the hole in the middle, what we're going to do is we're going to say the volume itself, the volume that we're trying to find, is going to be equal to the volume of the whole prism, which I'm going to call VP, minus the volume of the whole cylinder, which I'm going to call VCL. So the volume we're looking for is VP minus VCL. Okay, now let's find the volume of the prism. Start there. The volume of the prism is going to be the base area times the height. Now the base area would be 20 times another 20 because we were told that it is 20 on each side. So that's going to be 400 square millimeters times the height of 35 times 35 millimeters. Multiply those two together and we get 14,000 cubic millimeters. The cylinder on the inside, VCL, is also the area of the base times the height, but the area of the base is a circle. It's a circle with a diameter of 20, which means we have a radius of 10. Okay, and we're going to use pi r squared as the area of the base times the height. Let's plug into that. So pi times 10 squared times the same height of 35. The volume of the cylinder, when we multiply those together, we get about 10,996 cubic millimeters. The total volume would be 14,000 minus 10,996. There's too many nines there. And that comes out to about 3,004 cubic millimeters. Would be the volume of the shaded region left over. Number 6. A prism has the bases of an equilateral triangle with the side lengths of 10 inches and the lengths of 30 inches. Determine the volume of the prism to the nearest cubic inch. So let's break this down. We want the area of this equilateral triangle essentially times the 30 times the depth, and that will give you the volume. So we got to find the area of this. Well, that's 10 all the way across, which means it's 5 just to this point here. This side is 10 also because it's equilateral. This side is this side is this side. And what we can now do is let's take that triangle over here and let's look at it and use Pythagorean theorem to find the height. That side is 10, that side is 5, so A is 5, C is 10, and we're looking for B, which is the height. Okay, that's the unknown. So A squared plus B squared equals C squared. that would be 5 squared plus b squared equals 10 squared. B squared equals 100 minus 25, which is 75. B equals the square root of 75, which is about 8.66 inches. So that's going to be the height. The volume of the prism is the base area times the height. The base area itself is going to be 1/2 the base. The entire base is 10. So 1/2 of 10 times the height of 8.66. And then we're going to multiply that times the height, or rather the depth of the prism, which is the 30. And when we multiply all that together, we get about 1299 cubic inches. Question 7, the shaded prism below is created by a rectangular box as shown. Points A, B, C are the midpoints of their respective edges. Explain using Cavalieri's principle why the volume of the shaded prism must be 1/4 of the volume of the rectangular box. Well, let's let each side of the box, equal S. That means, guys, the volume of the box is going to be the area of the base times the height. And the area of the base would be S squared times the height. So in other words, we get S squared H as the volume of the box. Now the volume of the prism inside is also the area of the base times the height. But here's what you have to look at. The area of the base, guys, is a triangle. So you have to go area of the base of the triangle times that height right there. Same height. So the area of the base is going to be 1/2 of 1/2 S times S. Think about that. You're looking at a triangle down here where this is a full side S, and the base of that triangle is 1/2 S, and this is a full S. So 1/2 of 1/2 S times S is the area of the base. Multiply that times the height, and we get 1/4 S squared H.